Hi, my name is Zhijia Zhang. This will be my pre-work for a tech fellow for the intermediate technical interview prep course, TIP 102. Um, just a little bit of background. I'm a student at the University of Pennsylvania studying computer science. Um, Yeah, and over the summer, I was a student in TIP 103, which is the Advanced Technical Interview Prep course. So I'm pretty familiar with the structure of of these courses. So let's get right into it. Prompt number one. The prompt is that imagine that I'm a tech fellow in a breakout room with a couple of students, and a particular student asks me to answer a question that I don't know the answer to, and so in that case, what would I do? Now, I think the most important thing here is that you should pretty much start by acknowledging that you don't know the answer, right? What we don't want to do is kind of like make up something or give an incorrect answer. So definitely acknowledge that you don't know the answer. And I think being honest and transparent is probably better than trying to make something up. And then after that, I would propose to look up the answer, either by myself, and get back to the group after I find the answer, or we could look up the answer together. And there's like a lot of resources out there. We have the course portal. There's a lot of great verified resources in there. There's also slides. And this approach really shows or demonstrates good research practices and shows that learning is a continuous process. Um, and after that, I would encourage group discussion. So students can kind of discuss what they learn about the topic and the question that they initially asked. And lastly, I would just ask follow-up questions. If if the student has any follow-ups to the original question, I would be happy to answer those. Um, and also, if I couldn't find the answer, or if we couldn't find the answer, I would probably research the answer outside of class, and get back to the student later, perhaps on Slack or something. So that would be my answer for prompt number one. Let's see how we're doing on time. Okay. Prompt number two, we have. So basically, I'm in a pod breakout session, and all the cameras are off, and essentially no one is participating. What would I do? So basically, I guess when I join the group, I would start by addressing the group warmly and expressing enthusiasm about like today's questions or topics. And I think to actually get the students to engage, I would directly address each student by name, and like maybe ask them like a specific question related to the topic today or how their day is going, right? So like this type of like personalized attention, it can really encourage the students to turn on their cameras and engage. And I think the last two things I would do is just have interactive activities. So usually like during these group out sessions, what students are doing is solving a specific LeetCode question. Maybe I would like encourage one of the students to take the lead on solving the questions, and I would encourage group discussion so that all the other students who are also in the breakout room, they could share their thoughts about the question, and everyone can kind of interact that way. So that would definitely encourage a lot of engagement in these breakout groups. Lastly, I will be explaining binary search. So basically, the prompt is how to use binary search to find an item in a sorted array. Answer should provide a target number and index. If the item is not in the array, return -1. So basically, to start, what binary search is, It is a efficient search algorithm for a sorted array. And the key word here is that the array has to be sorted or binary search does not work. And essentially the way that the search works is that you have your original array. You're usually given an array. You're given a target. Target is like the number that you are looking to find in the array. And basically, you start out with two pointers, what we call pointers, and they're on. One is in the beginning of the array and one is at the end of the array. And basically, what we do is we repeatedly divide the search interval in half to look for the target number. And what I mean by this is that let's just take a look here. So here we divide the search interval in half, right? We haven't divided yet, but we get the middle position between these two left and right pointers. And we see that it's on 4, right? Now, we ask ourselves, is 4 our target number? Well, it's obviously not, right? And so then the next question we ask is 4 less than or greater than 2? Well, it's definitely greater than, right? So what can we conclude about this? Well, we know that if 4 is greater than 2, right? Because the array is in a sorted manner, that means everything to the right of 4 is also greater than 2. So in that case, we don't need to search this entire portion of the array. And we can just search this left side. So essentially what we do here is we move our right pointer 1 to the left of the middle position. And this is our newly searched interval. And essentially we just keep continuing that process until we either find the element or if the left and the right pointers cross each other, then that means the element is not in the array. And before I get into the code for it, I'm just going to give a quick runtime analysis. So the runtime is O of log n, which is extremely well. It is significantly better than, I would say, O of n time, significantly better. And n is the length of the array. Now, I don't want to get too complex into the runtime analysis here, but basically the idea is we take an original array, right? We keep dividing the search space by 2. So in this case, we divide by 2, and then in this case, we find the array, right? But if not, we find the element. But if not, we would divide it by 2 again. So essentially, log n is essentially equal to how many times can we divide by 2 to reach 1, right? And because we're continually having the array, this is mathematically equivalent to taking the log of the length of the array. Okay, so I'm going to get into the code. The code is pretty straightforward. It essentially follows what I've explained up here. So basically you start out, you initialize 2 pointers, one in the beginning, so index 0, that'll be your left pointer. You initialize a right pointer, which is at length of array minus 1. We have to account for minus 1 because the array is indexed. So basically, we keep iterating while the pointers have not crossed each other, right? As I said above, if they cross each other, that means that the element is not in the array. So basically, in the loop, what we do is we have a middle point. We calculate this point by taking the positions of the left and right and dividing it by 2, floor division by 2. The reason we do that is if this sum right here is like an odd number, this takes care of finding the middle position of that. So basically, we essentially find the middle position of the search interval, and we ask ourselves, is this number at this position the target? If it is, I believe the prompt set to return the index, so we just go ahead and return mid, which is the index, right? Now, if this number is greater than the target, so a lot like this example up here, then we no longer have to search this entire side, right? So we would just move the right pointer to the left of mid, right? And we will essentially be searching this side. Now, the other case would be if array of mid is less than target. So that will be the case. We don't have to search the entire left side to the left of this midpoint. And we can just move our left pointer to mid +1 so we can search the right side. And essentially this keeps repeating itself, repeatedly having the search interval. And so if the element is in the array, this condition here will execute, right? Eventually we will find it. But if we don't, we just have a return, we return -1 here. And that indicates that the element is not in the array, right? And it was never detected in the loop. And yeah, I think that's pretty much it. And I just have 2 examples down here. So we call binary search on this array. 8 is our target. So obviously 8 is in here, in the array. So we are expecting index 7 to be returned. That is the position that 8 is in. And then in this second example, we have the same array, but our target is 12. Now, obviously 12 is not in this array, right? So we would just go ahead and the algorithm will return -1. So if we go ahead and run this, yeah, we get the expected outputs. Yeah, so that concludes my explanation of binary search. And I believe that also concludes all 3 prompts as well for this pre-work. Really enjoyed going through the prompts, explaining a technical question out loud. And I would love to join the Tech Fellows team in the spring of 2024. Thank you so much.